plus c, not times c. In differential equations, you get times c pretty often. What is... Wait. What's happening here? Maybe Don knows why the chicken crossed the Mobius strip. I mean, no, I don't know. I was trying to think of some clever joke, but the absolute value in this thing is scaring me. Let's see what it looks like in Wolfram Alpha. Wait, was it 1 minus x squared? Yeah. So there's no doubt that this continuity between 0 and 1/2. Oh, it kind of looks like a cosecant or secant. I'm really confused about what this chart is supposed to be, though. Wait. The absolute value bars seem pretty pointless because the function is always positive over 0 to 1/2. I mean, it's always positive in general, isn't it? Well, if x is less than... No, if x is greater than 1. Wait, why did the Wolfram Alpha not... Oh, because I did the absolute value, duh. If I remove the absolute value, I should have done that. Confusing myself. But either way, between 0 and 1/2, it's definitely positive. That's how it's supposed to look. Oh, that's actually not like secant or cosecant at all. It was the way that it cut off that made me think like that. Oh, did you put in the actual integral, Jed? Zero to 1/2. Yeah, actually integrating this is going to be... I assume it's partial fractions. SGN? Sine of x? Oh my god. Oh, because of the absolute value, but it won't look as bad. No, I think as partial fractions, I don't think it's going to be that ugly over the actual interval. Yeah, but I'm not sure why they're considering things outside of 0 to 1/2. So they're looking at like the signs, I guess, to figure out if they can drop the absolute value bars, but I'm not sure exactly. Oh, that's just... inverse hyperbolic tangent? I'm much more familiar with the logarithms, but... Huh. Yeah, that... Um, 100% sure I'm reading it correct. Or do... Oh, it's a subset of -1, 1. That's a very... Yeah, you're... Okay, yeah, they probably are told to make sign charts like this because you have to split it up into multiple integrals. Like if it changes from positive to negative partway through the interval. In this case, we're safe though. Okay. I guess that's the potential utility of making a chart like that. Okay, let's see what Bob said. Yeah, because... Yeah, Jed, that's kind of like... There's some interpretation there. Okay, that's a really nice way of putting it. Sure, IBD, but... Stuff, I mean, like, that exact form isn't quite right, but I'm just saying, like, the idea is right. A over 1 minus x plus b over 1 plus x. I think. Yeah, I think that's what they're asking, Jed. Basically, pi r squared and pi, I guess it will be 0.8r squared, assuming the maximum error happens. See what Bob has to say. Or if they take a minute to type back, I guess I'll look at in other text channels, but that's why I'm on this train of thought. Finding the derivatives and then adding them would take a while? Are they doing some fancy, like, Feynman integration or something? I'm not going to address that part of it, but I'm just going to say sounds good. If they're deriving, they're doing some really weird technique. Sent it? Let's see. Oh God! All right, let's make this bigger. Let's see if Opera is feeling better. The population of chimpanzees in a particular... Oh, you're doing this? Oh no! This is stuff I was doing in the last year of my applied math major, but like, I guess this is going to be in a sequence, not as an actual continuous like differential equation. It's like a recursive sequence version of stuff I was doing, I guess. Oh my God. Okay. Well, let's see if we can get through this one. The population of chimpanzees in a particular country consists of juveniles and adults. Juvenile chimpanzees do not reproduce. Okay, okay. Oh, is this related to Markov chains? I've heard the term. I don't know how they work though. Okay, so there's a small a right there as a constant. J sub n and a sub n are the respective numbers of juvenile and adult chimpanzees n years after the start of the study. Determine the meaning of the constant a in the context of the model. We shouldn't need the actual an actual Markov chain to do this. It's just going to be matrix stuff. So it's not a stochastic matrix though. I don't know what a stochastic matrix is. So we could equivalently translate this as if we were to multiply this basically vector into the matrix, we could make it into a system of equations. I'm just gonna write it on the side of the board here. Is that good spacing? Okay, good. J sub n plus 1 is equal to a J sub n plus 0.15 a sub n. Then a sub n plus 1 is equal to, is that 0.08? Yeah. Plus 0.82 a sub n. That j looks like a weird 0, doesn't it? Ugh. That's a small j, but you know, who cares? Not me. Okay, so the wording for the answer part A is very specific. See, if you have to word it a specific way, I wouldn't know how that's supposed to be, but to me, it seems like the A in this situation is going to be something to do with the proportion of chimpanzees being born, or, you know, entering the juvenile phase. It's kind of weird, though. I got it right? Okay. Let me see what you just posted here. Or more detail needed. Oh, is the answer? You gotta write any specific word, more detail needed. Like the specific word is maybe the proportion? Of chimpanzees, or also the juvenile monkeys survive. Oh, okay. I didn't think about that. Yeah, it is a mean question. Okay, so I guess that's okay for A. At the start of the study, the total number of chimpanzees in the country was estimated to be 64,000, according to this model. Part D, maybe you have a brain explosion. Should I skip down to part D, or should I work through like B and C first? Continue? Okay. According to the model, after 1 year, the number of juvenile chimpanzees is 15,360. The number of adult chimpanzees is 43,008. Find, in terms of A, the inverse of this matrix. Are we going to need this for... I guess we will need it. Okay, I don't say that to how, but okay. Now I remember how you find the inverse of a 2x2 matrix. I remember it's like it's 1 over the determinant and you like switch the corners or something like that. Oh my god, Opera is still being stupid. It's freaking browser, man. Swap the top element, top left element, bottom right, make the other elements. That's right. But you also need to divide by the determinant. Okay. Makes sense. Bring up the question in this browser too. I'm just gonna not use Opera today, I guess. Okay, so let's find the inverse of that matrix in terms of small a. So we have A, 0.15, 0.08, 0.82. Inverse. So switch the top left and bottom right. Wait. Let's figure out the determinant. 1 over AD minus BC 0.15 times 0.08. That's like 15 times 8, which is like 30 times 4, which is 120. Move the decimal to the left 4 places. 0.012? Is that right? Did I just do some genius mental math right there? It's not really that genius, but it's 0.08. Correct? Oh, I actually did something right for once in my life. Okay. And the actual matrix, do a little switcheroo for those two, then do negative for those two. Think you bring that multiple in. I don't know if it really helps you that much. If you get part D, I'll give you a virtual cookie. Oh, I did not negate CGen. You were absolutely right. Ah, God dang it. One day I'll get an actual tripod for my camera. So I don't have to worry about bumping my desk. Earthquake. Hey, I'm in California. Hence our lights find the value of A. So this is the part where I was getting a little like weirded out. So I read ahead to this part. So yeah. I have to constantly repeat it and have a California related flag because if you're a Californian, you have to be really proud and like looking down on others about it. So we have to use some of the information that's kind of in the preamble here. So at the start of the study, total number of chimpanzees in the country was estimated to be 64,000. According to the model, after 1 year, so oh wait, we don't need that fact yet. We can find the value of A by multiplying the original matrix and its inverse and setting equal to the identity, can't we? Okay. I think that's how we're supposed to do part 2 here. So we have A, 0.15, 0.08, 0.82 times, I guess I do need to bring in the determinant. How annoying is that? We don't need to do, we can make this easier on ourselves though. It's a lot of writing. We're not going to need to use this entire matrix though. We're only going to need to make one equation out of this. Okay. So what I did is I multiplied our original matrix times its inverse and set it equal to the identity, because that's the definition of an inverse matrix. And now we know that this one, for example, comes from the dot product of that row and that column. So we could set up that, or we could try to look for an even easier one. Like the 0 comes from that row in that column. Maybe 0 is an easier number to work with. So let's try that. So A times the element there minus 0.15a over 0.82a minus 0.012 plus that times that. Wait, that doesn't help you solve for A, does it? Is this not right? Why are these nearly the same thing? Hey Felix, you also just do RREF on the original and then do the same operations to the identity. Oh, that might be it too. Or that's a way of finding the... You need to reconsider the numbers. Use the numbers given. I do use the numbers that they give you? Give me? But... So I definitely think the way that I was thinking is bad. So I just get things that cancel out with each other. Yeah, SPQ, I think you're right. Just that it's not equal to 0, but we can't actually solve for A with that. So I guess we do need to... Okay, we do need to use the numbers here. I thought it'd be for part 3. But okay, I guess this is our J sub n plus 1. This is our A sub n plus 1. And then J sub n plus A sub n is 64,000. I don't know exactly how this is gonna work, but let's try it. So J sub n plus 1 was 15,360. A sub n plus 1 is 43,008. I was confused by them telling us to get the inverse matrix. I guess we'll need it for this step though, won't we? J sub n, A sub n. And we also know J sub n plus A sub n is equal to 64,000. Is how I'm interpreting the numbers that we've been given. So I guess this is where we need to use the inverse and left to multiply each side. Or just make it into a system of equations. Is one easier than the other? I feel like a system of equations makes more sense to me, at least. I'm just kind of debating this. Yeah. In Thunder, you have to make simultaneous equations, so I mean, or maybe that counts, but I'm just making this in the system of equations because I feel like I'm less likely to mess that up. So we can turn this into 2 equations and 2 unknowns with this fact here. Let's get rid of... You haven't done it this way? Oh, you're supposed to left multiply? Okay, I'll do it that way then. This way would also work too, I think, but I'll do the left multiplying. We did go through trouble finding the inverse, I guess. It's just, I hate the look of the inverse, so. 012 times that. I forgot like half the equation here, didn't I? Okay. Oh, that's right. Yeah, they do say hence. You're right. Okay, so makeshift multiplication may not be commutative, but it sure is associative as far as I know. So we can just do this part and then worry about that part second. I think 2 by 2, 2 by 1. We expect a 2 by 1 answer. I'm really glad that I just watched Penn Center's video on matrix multiplication because I'm so bad at it. Here, the top element is going to be 15,360 times 0.82 plus 43,008 times minus 0.15, which that seems like work for a calculator. AKA Wolfram Alpha. .82 times. Are you allowed to use a calculator for math like this, Thunder? I really hope so. Allowed? Okay, good. $61.44. The bottom element is that column times that row. Oh, and what I just pointed to was covered up, but you guys will get the idea, I'm sure. So 15,360 times... Stop shaking. I need to never touch my desk again. Oh, well, we have an A involved now. Don't we? So let's just see what this number is. 61... I guess we're doing decimals. So 1228.8. So yeah, no, this isn't as hard as I was making it sound at the very start, but the exact setup to this question is like, there's like a calculus version of this that is some of my favorite things to do in math, but it's not exactly easy. Okay, so now what? We can multiply in our scalar. I guess let's do that. I mean, it doesn't make a huge difference, but let's just do it. I think now we're gonna have to use this fact here. Minus 0.012. The equation now would help? Okay, yeah. So let's change this a sub n into... a sub n is equal to 64,000 minus j sub n, so let's make that sub. Okay. God, that's horrible. I hate looking at this. I think over to the left side of the whiteboard. Okay. So across the top, we have an equation there. Minus 1228.8 plus 43008A over that is equal to 64,000 minus j sub n. So I want to add these two equations together, just get rid of the j sub n's, I think. There's a common denominator here too, thankfully. Makes the work slightly easier. Ah. Oh, 64,000, wasn't it? Yeah, I just wrote it wrong. Okay. Now multiply through by the denominator. Do that math up there. Dude, that's not mental math for me, though. You know what? Wolfram Alpha can handle it from here. I've done the hard part. Let me type this in. Okay. A is 0.6. All that work. Okay. That's B part 2. A is 0.6. Okay, good. Felix, we just did B part 2. And now I'm looking at part 3. It was in a minute that can let you draw things like cylinders with given radius and height. Yeah, Felix. Ah. Find in terms of A, the inverse of the matrix. My answer to that is right there. And Niram, of a given radius and height. I don't know, Jed, are you around? Do you know if GeoGebra does 3D? I think it does. If not, I'll just go into GeoGebra and try it for myself quick. Let's see. Cylinder. Select 2 points, then enter radius. 1. Oh, okay. GeoGebra is what I would tell you, Niram. I'm not the expert in using GeoGebra, but it's probably going to be the easiest one. It's like you make 2 points to make the height of the cylinder, and then you manually enter in the radius. Awesome. Glad to help. Okay, so part 3. Calculate the change in the number of juvenile chimpanzees in the first year of the study. Oh, Desmos has templates for it? Okay. Yes, Desmos is my other option. I assume it'd be a little bit harder to do it, though. But if there's templates, that might just make it easier. Change in the number of juvenile chimpanzees in the first year of the study according to this model. So we really just need j sub n, and we already have j sub n plus 1. So we know that A is 0.6. And so we can plug it into one of my original equations from the system to get j sub n. Decimal cylinders are you give a save file. Oh, nice. Okay. So I'm going to type in one of the equations I drew on the board. I know that you guys can't see it though, but just trust me. 0.82 times 0.6 was our A, minus 0.0012. So J sub n is 12,800. J sub n plus 1 is 15,360. So we need 15,360 minus this. So the change in chimpanzees is 2560 for B part 3. 2560 is correct. Awesome. Given the number of juvenile chimpanzees known to be in decline in the country, comment on the short-term suitability of this model. Yep, Felix, go ahead. Links are turned on without anything special need to be done, yeah. Yeah, I'm kind of curious to see how it looks for myself, too. Just, Oh, yeah, no, I know that at some point I'm going to have to turn links off in my chat, I think, if things get too busy. But no one's abused it yet, so I don't want to turn it off until I have to. Oh, does the blue cylinder use that as the height? Interesting. Can you claim first on that too? Claim first on what? Yeah, that was a little weird to me, but I guess it doesn't make a difference. Oh, abusing links? I mean, you can see what happens. You can be first, but you're gonna find out what happens. Unfortunately, you would not be my first ban, though. That's already been claimed. I mean, part of the first person ban was like some bot spamming that I should pay them to help grow my channel. Okay, so given the number of juvenile chimpanzees is known to be in decline in the country, comment on the short-term suitability of this model. So are we supposed to maybe do some iterations here? We figured out what the initial we figured out, or we can figure out the initial populations J sub n, A sub n, or basically J sub 0, A sub 0, because they say at the start of the study. No math needed? Just comparing numbers? So you need to find a number, as in like finding a number, not as in solving an equation, but literally just like looking at a number. Yeah, because I'm thinking like all these numbers are less than 1, so all these numbers are decreasing. Or, you know, for every iteration, J sub n plus 1 A sub n plus 1 are going to decrease, I think. You know, I'll say without giving the answer, that's fair. I guess you have two separate variables here. Well, so I know we don't have subtraction, but we are taking percentages less than 100 of our previous years. So I guess if they were to, it depend on the initial values, maybe. Oh, excuse me. Juveniles before and after according to this model. Well, okay, so for juveniles, they're changing with 0.6 times the last year's juveniles plus 0.15 times last year's adults. It seems like it's going to be decreasing a lot. Those are not very high. I mean, 0.6 is a decently high percentage, but 0.15 is very low. And 0.6 is still a pretty hefty chunk taken out. Cannot believe you'd ban me if you abused links. Truly, yeah, I know, but if you don't just have a free pass to do anything. I'm kind of mean like that. Wait. It did decrease, I thought. Because after 1 year, no, it did increase, you're right. That's the n+1. Well, what the hell's the point of this model? I wasn't thinking it'd be complete garbage. The next part explains it? Okay, I was like, I was just giving it some credit. But I know what minus signs, but this is like a recursive formula, and you're reducing it by such a big percentage that I thought it'd be declining. I guess not. The next part is insane. A study of the population revealed that adult chimpanzees stop reproducing at the age of 40 years. Refine the matrix system for the model to reflect this information, giving a reason for your answer? There's no need to estimate any unknown values for the refined model, but any known values should be made clear. So you get to name like a bee or something here? Virtual cookie if you get it. So, okay, let's look at each of these numbers in the matrix and try and look at what they mean. So kind of part A is relevant here again, I think. So the A, which is 0.6 that we worked out, is the number of baby chimpanzees becoming juvenile and the number of juveniles surviving, or that kind of like proportion. The 0.15, well, the adults aren't reverse aging, I would think, but I feel like it's this 0.15 that would need to get changed. Does that represent the adults giving birth to chimpanzees, I would guess, which is where I think we'd have to make a change here. And it does make sense that our juveniles were too high, according to the model. Juveniles are always getting high, right? And the second row here, the 0.08 times last year's juveniles is the juveniles coming of age, I would guess. And the 0.82 is the number of adults that survived that year, proportion of adults that survived that year. So I guess we will take that 0.15 and I can't imagine we have enough information to have a known value. Like maybe you could come up with something based off if you knew the entire lifespan of a chimpanzee and like reduce this by the proportion that they don't reproduce or something. But I think you just need the 0.15 to be B or some other arbitrary constant because they say don't estimate unknown values. So I think my refinement is just to change the 0.15 into a B, basically, for the reasons that I stated. Wrong? What do you do? Try again. Okay. It's a lot more fun? Fun? What about this is gonna be fun? Oh, painful. Okay. That makes sense too. Whew. 15,600,000. Well, you're calculating it for like the 15,360 is like our 0th year. No, sorry, that's already the J sub n plus 1, 15,360. Which I guess we can treat that as the first year because it's after 1 year. So I think what you calculated there, Felix, is like basically the J sub 2. If this is our J sub 1. Which is still increasing. Which means that it's not agreeing with the observation that they're declining. You don't want to wait 7 years. It probably would take me that long to get that. It's a 3x3 matrix? Oh! You add a third row and a third column for like elderly chimpanzees, or you know, however you want to define them, for once they've stopped reproducing. That makes sense. That now that you say that, I've seen that exact thing before in different contexts. But it didn't come to mind for me here. So you still don't know how to do the second mark. Do you have to actually make... I guess you would have to actually make the matrix, and then sort of dark wizardry do you do to make the model? I'm trying to figure out if we can just make everything constants to those field songs. Sad cat in the background. Well, you know, that's because I have to do this problem involving chimpanzees. You know, that's why I'm sad. So, okay, let's... I'll try and draw out on the board what I'm debating here. Oh. I think that marked back here. And let me take down the webcam, because I keep forgetting. So... we have J sub n plus 1, A sub n plus 1, and then maybe I'll say senior chimpanzee, S. We have 0.6. I mean, these might change too. I guess the juveniles would say the same. Why is there a sad cat? Blame Boo did. I had to draw it. So I think our values for the juveniles will stay the same here, but all of these other values seem like they're subject to change. Because the adults previously included the seniors, but now we're splitting them, you know, not necessarily in half, but in 2 pieces. So I don't know what more value you must write to get the mark. We can figure out one of these values? Let me think about it. Probably not gonna get it. I think the number of seniors wouldn't affect the number of juveniles. 0. Because seniors can't reproduce. Is that right? I get a virtual cookie. Hell yeah. I mean, I must say, just think about it, even though I hate it when people say that. So the seniors can't reproduce, so they can't have an effect on the juveniles unless you want to make some argument about like competing for resources, but this model doesn't seem to account for that in the first place. Oh, I don't think you can say it's a proportion like that, Felix. Is it? No, because you're getting like it's like population. There's like age distributions that you'd be getting into if you're going to go there, I think. Yeah, I mean, assumption, I guess, is yeah. Oh, that's 0. The number of seniors, I guess, wouldn't affect the number of adults either. They say M. I don't know what M is supposed to be, but either way, it doesn't matter. Hey, like I said, well, maybe they won't spell it jam, you know? Underline 0 must be correct, but do not be concerned about any values used in the other entries. Okay. Well, I got the important 0, I guess. I could have made the same realization about the adults, but... this is kind of dumb because the seniors are competing for resources with the others, so surely they would have some effect, but... So, okay. It's because the model just straight up doesn't cover every situation. They're talking about only in terms of reproduction. I guess, and surviving, though. That doesn't... I think they're trying to make you not overthink it. And with the hint they've dropped that adult chimpanzees stop reproducing after 40 years old, what they're trying to tell you is that the senior chimpanzees can't affect the juveniles because they're not reproducing. And I think they don't want you to think any farther than that, even though the reality is kind of different. Supposed to be done 30 minutes ago? Oh my god. So, I mean, I guess, I take some detours as I explore these questions, and I try different ways of solving it, but that's still, like, that's a hard question to do quickly. And thinking way too precisely. Yeah, Felix. I like how seriously you're taking it, but I think overthinking this question is a mistake. Those chimpanzees, man. You got anything else, Thunder? If not, I'm just gonna do some random practice problems, I think. Oh, you still don't understand the last 0? Okay, so... Am I assuming that like the underline 0 there? So rather than the 1 for adults, I mean, they're kind of the same idea though. Or they really are the same idea. Okay, so maybe rewinding back like to part A, where you're supposed to explain what that A means. We or like I think the question is like how we're supposed to know that it is a 0. Or I assume Thor knows that it's like required to be there. Yeah, so basically, if we kind of recap what this first line means for the juveniles, the A or the 0.6 is baby chimpanzees coming of age and existing juveniles not dying. And the 0.15, I think, is from the adults reproducing. And the adults have no other effect on the juveniles that I can figure out. And so if we add on another column for the seniors don't reproduce, and I can't figure out any other justification for why the seniors would affect the juveniles. That's why I came up with 0 there. Now you can make the argument that the seniors are still eating food that then takes food away from the juveniles, but the model doesn't seem to think that far ahead. So that's kind of a confusing part of it, but I think they're thinking mostly in terms of reproduction. And since seniors don't reproduce, they're not making more juveniles, so the number of seniors doesn't affect the number of juveniles for the sake of this model. You know, if they're not reproducing, they're not making more juveniles, I guess. Yeah, I think that's the idea that they're after, even if the execution feels a little weird to me, or a little hand wavy maybe. But I think that like sentence before D is supposed to be your hint that you're supposed to think about in terms of reproduction. You don't know if you're supposed to know how to do? Okay. You got it? Okay. That is kind of like, even though it's annoying, it is kind of a fun question, because I might immediately went to calculus because you can get like y sub 1 prime, y sub 2 prime is equal to a matrix y sub 1, y sub 2, and you have to solve that like system of differential equations, and it gets kind of crazy. And it's also can be used to model populations, but we don't have to go quite that far. Let's see what Thunder posted. Oh God. Let's see what this drawing's about. Moving to vectors. Yeah. Evil face indeed. The points A, 3, 2, -4, B, 9, -4, 2, C, -6, -10, 8. Oh, I do have a hard stop in like 20 minutes, just as a warning. I'm gonna have to cut the stream off after that time. I completely forgot to check the time, so I didn't realize that. The verse of the tetrahedron. So the tetrahedron is this entire, not quite pyramid thing, but kind of pyramid thing. Tetrahedron is the proper word, I've heard. The plane with the equation C equals 0 cuts the tetrahedron into 2 pieces, one on each side of the plane. Okay. The edges AB, AC, and AD of the tetrahedron intersect the planes at points M and P, respectively, as shown in figure 1. Okay. Determine the coordinates of the points M and P. The area of triangle M and P. the exact volume of the solid BCD PNM, the truncated tetrahedron, I guess, with the little bottom part cut off. Okay. Well. So I want to do this algebraically, which involves finding the equations of the lines from D to A, from C to A, and from B to A, and finding where Z equals 0 along those lines, and that will be the coordinates for M, N, and P. Cross product. Oh yeah, I tried to use the cross product with you before. But yeah, your thing for planes did it differently. I remember that. I can teach you cross product quickly. Once we get to that part. Or we can skip it if you already know and skip straight to that part if you know that, but. So I'm trying to think if there's a different way to do this that's more vector focused. Just need to know if it's possible without cross product. It's possible with calculus. I don't think that's going to help you either, though. Try to learn it in your own time? No worries. There might be a formula for this, but so I know we don't have this isn't a tetrahedron. I just want to see, not for regular tetrahedron. I just want to see like what comes up for a tetrahedron in general. Yeah, Felix, that's my instinct too for like the first part. The thing is, you have to do that 3 times, and it's kind of annoying. I don't know if there's a more efficient way. But Thunder seems to be asking about part C and alternative ways to do that. So I'm going to focus on that. What is that? I don't want to know. I don't want to know what that is. So we have an irregular tetrahedron, I guess, which is probably a lot harder. Okay, I don't see anything that is that convenient here. One sixth A cross B dot C. That's the formula. Does it matter which one you use for A, B, and C? Okay, yeah, so that's the same formula there. So we could, you could compute that formula for generic vectors and get some crazy some crazy formula. No, Jed. This is the original problem as Thunder sent it. And actually, this is the volume of the entire tetrahedron. We need the exact volume of... Oh, so you do the entire tetrahedron minus the top part of the tetrahedron, and that's your answer. So I'm trying to think if it's possible without cross product. It would be a very crazy formula, I think, for an arbitrary tetrahedron like this. You could in theory get a formula from this thing that you posted if you knew what a cross product is and did it with like generic vectors basically. But it's going to be crazy. Yeah, Jed, so there is a formula for this situation, but Thunder's asking if there's an alternative to the formula that the basically like this is like the book answer for what you should do. And Thunder's just asking if there's an alternative to this formula, and I'm not aware of one. I could try and find one. They say 3 factorial instead of just saying 1/6. That's how you know you're a Chad with math, I guess. Okay, this Google search doesn't come up with anything. I don't think I have an idea for you. Wait, no way. Oh, that's for a specific case, I think. Okay. So yeah, Jed, that's the idea we have to use. It's really just avoiding this cross product. Is there a separate formula to get the same volumes? So you can do that same ABCD minus AMNP trick. Oh my god, that hurts my brain. What the hell is this animation? Huh. Volume pyramid given the coordinates? Basically, Jed, yeah. Is there a way to avoid the linear algebra part of this? And so you could always just use generic vectors and compute the cross product and then the dot product. And that's a formula there, but it's going to be crazy. Like, or I assume it will be. Like, it's not going to be anything simple. In 2D? I guess so, yeah, Felix. Brain fried. Yeah, Thunder, I don't see a way to avoid the cross product here. So I think the answer, at least for me, is no, you can't avoid it as far as I can find. Yeah, you're probably right, Felix. So it sounds like you're okay without it, but if you did want to actually see it computed, I'd be happy to. But if you don't need to see it, then I'm gonna leave it. Okay. This is a really tedious question. For me to solve it, to do all 3 of these parts the way that instinctively comes to me, it would take a long time to actually like work through all the calculations. So I'm glad you don't need to see that, it sounds like, either. If you have anything else, feel free to post it. I still got 10 minutes before I should turn the stream off. Still find the height, which is hard because you have to figure out the perpendicular to the BCD plane through A. Yeah. I don't even know how that would work. I don't want to think that hard. Let's see what Shapley values are. The equation for calculating them. This might not be the picture. Oh, okay. Oh, no, not, well, okay. I see. That looks horrible, yeah. It's a whole mess of symbols. It's my notification. Oh, I got a sub on YouTube, hell yeah. Okay. Heron's formula. Well, even then, if you get the area, do you can you bring that to be the volume? Oh, is there someone new in Discord? Okay. Hunter posted a new thing. Part B, how? Let's see how. Last question? Okay, good. The time we should hopefully work out here. 1/3 area base times height. Oh, does that formula work? Okay. So Thunder's asking you about part B. How do you do it? Explain why for k belongs to natural numbers, the sum from r equals 1 to 3k of r times tangent of 60r degrees is equal to minus k root 3. Using the results from part A. Oh, sorry, that's for part C. You know, that's a good question, isn't it? Now, there might be an identity here. There's, I think, product identities with trig functions, aren't there? Oh, not for inside. Okay, well, no. R is a natural number. Tangent of 60 is always something. If you didn't know, it is something. You know, oh shoot, Thunder, do you know the unit circle? No way. Somewhat know the unit circle. Oh, okay, good. As long as you're kind of familiar with it. So as we move through the sum, we're going to have 1 times tangent of 60 degrees plus 2 times tangent of 60 times 2 is 120 degrees. It's always going to be multiples of 60. And so tangent is going to always be the same thing, maybe with the sign changing. But we see, like, if we have r equals 1 and it's just tangent of 60 degrees, tangent of 60 degrees here is root 3 over 2 over 1/2 is root 3. Has period 180, good. And then when you get r equals 2 and tangent of 120, that's root 3 over 2 over minus 1/2 is minus root 3. So let's compute some values out here. Just so we can try and observe what the pattern is. Yes, y over x, Jed. Sine of x equals x for very small x. Yeah, if you're studying engineering, it's just whenever you want, but... So let's go through and compute some example values. Let's do red. I never use red. You know, actually, no, I'm going to save red for the next problem that makes me angry. That'd be better. Let's just use black. Okay, so we have K belongs to, oh God, how do you make this stupid shape like that? No, that's horrible. It doesn't matter though. R tangent 60 times R degrees is equal to minus K root 3. So I don't know exactly where this problem is going, but I think a good first step here is to compute some values and look at the pattern. So for R equals 1, we have 1 times tangent 60 degrees is equal to root 3 over 2 over a half, which is equal to root 3. Okay. If R equals 2, we have 2 times tangent 60 degrees. Oh, sorry. 60 times 2 is 120. Over, or equals, root 3 over 2 over minus a half times 2. So the 2 and the 1/2 cancel, so we get minus 2 root 3. Red is for wrong answers. You really ought to use it more. God dang it, Chet. For R equals 3, we have 3 times tangent of 180. Which is root 3 over 2. 3 times root 3 over 2 over minus a half again. Let me verify that. 180. No! Tangent's undefined. Oh, that's mean. Wait. Tangent of 180 is undefined. Is this just a... I messed up this pattern. It's not going to be exactly the same. Because 180 is the same thing as pi. So it's really going to be... Wait, no, y over x. Never mind. I'm bad at math. I know. Sue me. Okay, sorry. Let me show what I did wrong. It's 0 over 1. It's not 1 over 0. I lied. I regret it. So I was looking here, and I was like, oh, we got a 0. That's a problem. Tangent is, you take the y value divided by the x value. So it's 0 over -1, not -1 over 0. And I was even saying +1, I think, too, so I was double wrong. Okay. So that doesn't affect our sum. Maybe we might even do this down to 6 before I really see the pattern here, to be honest. 4 times tangent 240. Let me look at the unit circle, because clearly I'm not good at that. Which, of course, kicked you out. Oh. Well, hey, I made like 3 cents off you today, Jed. So, thanks. Okay, that comes out to be positive root 3. Okay. Four, I'm not going to show the cancellation, but it's minus root 3 over 2 over minus a half. Okay, 5. $300. Let me look that up again. That's minus root 3 over 2 over positive a half. So we get minus 5 root 3. Then r equals 6. 6 tangent 360. We've come, not, well, we're about to have come full circle if we do one more of these. Tangent of 360 is 0. And then, if we do another 60 degrees, we're going to be back at, we're going to be at 420. which is the same thing as tangent of 60. Because if you do one complete revolution and then add 60, you're still just at 60 for the sake of these calculations. So, but the coefficient is increasing, I should say. So, now we also have the upper bound as 3 times k. So we only ever end this sum at multiples of 3. So we end the sum at 3, at 6, at 9, basically always at a 0. And what we can observe here, oh, why is it 3k? Minus root 3, Jed, yeah. Why is 3k? Because you get a minus square root 3 every 3 terms. Yeah, Thunder, so that was 3k is just because it was given to us in the problem, and they engineered the problem so this nice pattern works out here. So 3k always corresponds with a 0. So, you know, people made the problem knew ahead of time that this pattern would occur, and so they specifically made it like nicer for you, thankfully. And so what you're supposed to spot here is that this set of basically like, you know, up to 3k for k equals 1, this adds to root 3 plus negative 2 root 3 plus 0 is negative root 3. This group of 3 down here comes out to be negative root 3 as well, if you add them up. So I'm trying to figure out how to phrase this next part, but we have, and if we were to go down to 9, we get the same equal to minus root 3 here thing here too. So we basically, now the task is to count how many of these root 3s, minus square root 3s we have for a value of k. So there's a funky thing here happening. You get it? Oh, good. Thank God. Okay. In that case, k equals 2. Yes, if you go down here. And so you do minus root 3 plus minus root 3 is minus 2 root 3, and k equals 2. So the formula works. Well, okay, not everyone starts the natural numbers with 0, Jed. So that's actually a tricky thing. It might also work for k equals 0, but not everyone starts n from 0. I don't know why. It's apparently a point of contention. Correct people do. Okay, there you go. So do you feel comfortable with the entire problem now, Thunder, so I don't explain things that you already understand? Because like I was getting stuck on how to explain the whole, we go up to 3k, but we end up with only k as part of the sum. But if you already have gotten that far, you had a little confusion? Okay, okay. I'll attempt not to over-explain things then, even though it's hard for me. You technically write 5k. You could, but then you're screwing up your formula for the sum. Yeah, you're not gonna have a nice clean formula. I think the formula only works with like 3k, 6k, like multiples of 3, because you get that nice like pattern of length 3. And so if the pattern happens to be 5 long before it repeats, then 5k would work. But yeah, it was very specifically engineered so that the pattern was 3 and you go up to 3k. Yeah, I actually went a little bit over time from what I intended to. If you have more questions, please do post them in Discord and I'll try to get back to you offline though. Penn Center would be streaming tomorrow usually as well. Or me or someone will get back to you offline, at least if you post them in my Discord. Yeah, no worries, Thunder. So I do have to end the stream there. Let me see, I don't think anyone usually streams around this time on Saturdays, but let me just take a look at Twitch. You post something perhaps? All right, up to you. Yeah, I don't see anyone doing math at the moment. So I think I'm just going to call the stream there. I'll do a general shout out to the math streamers that I know the best. And I encourage everyone to give them a follow because I know them well, could highly recommend them for all your math help needs. None of them are on right now, so I'm not going to raid. I'm just going to end the stream, but thanks everyone who's been hanging out with me, whether you're chatting or looking. I appreciate